Hello, we are Guy and Itai. We are students in the College of Management. This is a presentation of our final project in the Advanced Software Development course. Our project is a GUI that interacts with the flight gear simulator. The project is founded over 5 milestones, which will be reviewed shortly. The project development is based over the principles that we've learned over the semester. The first milestone was a development of a server-side that maintains the solid and grasp principles. We used the object adapter design pattern as well. The second milestone was an implementation of a polymorphic server solver and a cache manager. In addition, we used sockets and streaming for the communication. The third milestone was an implementation of the A* and BFS algorithms. The fourth milestone, major part, was the design and development of a custom language interpreter that matches the simulator functionality based over the command design pattern. The fifth and last milestone was a design of a graphical user interface for the simulator using JavaFX by the MVVM architecture and the observer design pattern. Now we'll see a short demonstration of our project. In the follow that in front of us, there is two batch files, run server and run client. Run server runs the calculation server that will calculate the path from our aircraft current position to a certain destination on the map. The server will find the shortest path by using the A* algorithm and BFS algorithm. The run client will launch our GUI, so let's see how it looks like. On the top left side, this is the terminal of our GUI. On the bottom left side, this is the terminal of the calculation server. On the top right side, this is the GUI as we designed it. And on the bottom right side, this is the simulator. So let's have a quick review over the GUI. We have two modes, manual mode and autopilot mode. Manual mode will allow us to control with this joystick over the aircraft. We can use the aileron and the elevator, the rudder and the throttle. The autopilot mode will allow us to run a script in a different thread that will control the aircraft. The script is written in a custom language that we develop. We build a specific interpreter for this language, which matches to the simulator functionality. There is 3 buttons over here: connect, load data, and calculate path. Connect will help us to connect to the simulator. Load data will load a CSV file that contains a matrix that represents the heights of the area. Specific in this simulator, it's a map of Honolulu. We take the CSV and we parsing it to a map. So let's see how it looks like. Okay. Now let's connect to the simulator. Of course, this is localhost at the moment. We can see over here that we connected successfully, and of course that we loaded the map successfully earlier. Over the map here, we can see that the green and yellow areas are the higher areas than the red over here. So we can take any destination that you like on the map, and we can connect to the calculation server, and the calculation server will calculate the shortest path by using A* algorithm and BFS. So let's see an example, and of course we can do it how many times that we would like. What's happened on the background that we send the coordinates of the aircraft position and the destination to the server with the matrix, and using the algorithms, we can print the shortest path over the map. So now, let's see the autopilot and how it goes. First, let's start the simulator, start the engine. Okay, so now I switch to the autopilot mode. We can see it right here that autopilot mode is on. Now we can load the script. As you can see, the script here is written in our own language. That in the GUI we have an interpreter that runs over the text over here and send a specific command to the simulator, of course in a different thread. Now we can see that our program is writing commands to the simulator, and as you can see, our airplane is moving forward and soon he will lift off the ground. So soon after he will lift off, we can move to the manual mode and to see how we can control the aircraft. It will take a second. So meanwhile, now we're in the air. We can look how it looks from behind. Meanwhile, the way that we control the simulator with the GUI and the script is with data binding. Actually, we take specific variables in the simulator in a specific path, and we bind them to a specific parameters in our GUI. So now we can switch to manual mode, and as you can see, the thread that was running the script is interrupted, and now we're on the manual mode. Now we can use the joystick to control the airplane. We can move the throttle back up. We have control over the rudder. As you can see over here, we can take a turn to the right, turn to the left. We actually have a full control over the aircraft. Now we can make a turn, move up, if we want to lift off a little bit more. And that's it. And now let's review the server side and the MVVM model that we implemented. This is the UML diagram of the server side, the calculation server from the demonstration that we just seen. We can see that there's an interface of a server with only two methods, and that there is a class, mySerialServer, which implements it. The server interface acts as an object adapter for the client handler interface, which is implemented by myClientHandler, which is also act as an object adapter for the solver and the cache manager. Now, in the perspective of our code, the server is actually a socket server. The client handler, it's a class that we've built, which need myClientHandler, that have a solver, which is the BFS or the ASTAR, and the cache manager, which act as the hash map that we can query solution that we already calculated. The server contains another two interfaces, searcher for the search mechanism and searchable for the data structure to run the mechanism on. We've separated these two for further development due to the open-close principle. This part is relevant for the calculation of the shortest path from the aircraft current position to the destination. We implement the BFS algorithm and the ASTAR algorithm, and we implement the searcher interface. The client side is designed by the MVVM architecture. The view contains the JavaFX configuration by the fxml file and the GUI controller, which acts as the controller of the view. The whole view acts as an observer to the view model. The view model contains the presentation logic. It is the active part of the architecture. There is a data binding between the view and the view model. The view model acts as an observer and as an observable. The model contains the business logic, and he acts as an observable. And this is the architecture of our client side. Thanks for watching!